CONCENTRIC. And it's been a great busy week here in Georgia with work not only in Georgia, but also some work across Europe and back to the Americas, and as always in Africa as well. And I've got a variety of updates for everyone. And if I know there's going to be the when's funding. Funding is kind of all the time now. It's going to be coming in from a variety of sources, and I know the guys with the crypto tokens will be, when are you going to pay dividends? And the answer to that is as soon as we get substantial funding, for a major project of some kind, which we have hundreds in development. And as we've talked about before, we have this modular plant single unit, which I'll talk about that a little bit tonight. We did a couple flyers, like kind of on the Lego modular theme, but at a $20 million mark, there's built-in profits in our EPC costs, so we would immediately roll out, at least $1 million type dividend. So that's always been in the works, and we have it's built into our bylaws. It's encoded in the Dow language, and that will be happening ASAP upon major project funding, which is what we're all working towards. And there's dozens of plants. I'm going to do my best here to get a picture up on screen. We've done a lot of screen sharing on Google Meet where we have some team meetings, but I'm going to look at this one, and I appreciate you guys with your patience over us coming up to speed. When I got criminally taken off the playing field of business back last decade, really early last decade, over a decade ago, that whole experience was certainly a strange time to be taken away, because as technology rolls forward in today's world, and by technology, everyone refers to it as digital phones and everything. Technology still means bricks and mortar stuff and rotating machinery and equipment and metallurgy. But most people refer to, how fast the speeds are. And I'll tell you, it's an amazing thing when you're off that playing field for a decade in today's day and age, and you come back out, it's a whole different world. So some of this stuff, I am an industrial computer programmer, even learned Pascal way back in high school, can program in all the languages, do PLC work. And I consider myself relatively computer savvy, but some of these things are a little challenging sometimes. And here's the deal. I'll throw this out just kind of as a comment. I will give a huge award to anybody who ever helps me use Discord. And that's going to be a tough one because I don't want to use it. That thing makes me dizzy. I guess it's awesome. You guys all say it's so cool. I've tried to get into Discord a couple times, and talk about a fish out of water. That's amazing. So anyway, that's a whole nother topic, I guess. But what we're looking at today with Concentric is the same development scheme. It just continues to grow for us. Part of my sort of, call it the brute force method, or I'm not really sure what to really call it, but my reaction to trying to raise capital is to build a pipeline of projects that are investment worthy. And that pipeline is mammoth now. And I want to show you a map of places we've been doing developments. And I'm also, if I can figure this out, how to share this information, I'm also going to show a couple of short videos. They're up in X and in what's it called? The video one is TikTok. And they're up there. Some of you in the group on our WhatsApp have seen it. I was in a discussion. What prompted that, and while I'm kind of learning these things, I'll talk this through. You guys know about our modular plant single unit, and if you don't know it, I'll try to give a quick background, because it's really the planet-changing technology, and for a variety of reasons. It's economically and ecologically kind of mind-bending, and to me it wasn't. I'm trying to learn some new language, because see, when you discover something that's so awesome, and it's a paradigm shift, it changes the language, it changes the way people look at things. You need to figure out how to explain that language. Well, as an engineer, I can go out and say, yeah, the thermodynamics are this, the energy balance is this, the returns on investment are this because we're making graphene and we make multiple products and there's diversified revenue streams and we've done all this before and we're just continuing to improve it. Now graphene's part of the mix because the new electric arc pyrolysis has come along, just like lasers and microwaves have over this past 10, 15 years, and all this stuff going on. And you say, yeah, you just have multiple revenue streams. The pro forma is simple: one thing in, fuel or waste, and you get a whole bunch of things out. Electricity, liquid fuels, graphene, aquaponic foods, clean water. You're just using the science to make all these things. That's actually pretty simple, right? I mean, what if you went up to a guy like Rumpelstiltskin? Remember, he could like spin straw into gold. Well, what if a guy just said, "Hey, I've got this science that spins straw into gold, and this is what it does," and it can make a whole bunch of money from straw, which is cheap, and turn it into gold, which is valuable. Well, if you read that story, I mean, everyone who, even when you read a fairy tale, you don't throw the book down and set it on fire because, like, how does he do it? I don't believe him. No, granted, that's a fairy tale, it's a story. But the thing is like healthy minds say, hey, if there's a better way, let's study it. Well, our stuff is actually pretty simple. There's a thing called biomimicry. Some of you have heard of that with everything. Hey, Zivor, good to see you. Um, biomimicry is what? It's just mimicking nature. In fact, if you even look at what steam is and or putting vegetable oil into a piston cylinder and igniting it, because the initial piston cylinder engines like Rudolf Diesel ran on peanut oil, which is just same constituency as cetane or diesel fuel. And so my point with all that is just harnessing nature to make things run better. And it's actually not that complicated if you're right there in the middle of it. You just take advantage of thermal energy, heat or cold. You make electricity, you convert products, you convert waste streams into other things. And then you explain that, hey, I've got something that can make more money from the same feedstock, the same fuel, the same waste stream. We can make more money because we make more products from it now. It's really, really that simple. Okay. However, you take that into the world who thinks one dimensionally. In fact, I'm thinking of a book now, and I'm going to mention this, and I'll do a review on it. It's really awesome. If you guys, it's called Flatland, and this is it's kind of the analogy I'm thinking of. It's a cool book. It's this allegory. I forget who even wrote it. I could look it up, but you could do Flatland. And if you think about it, if you're a point and you meet a line, you can't believe it. You're like, what do you mean? My life's just kind of this one dimension or no dimensions. I'm just a point. Then you meet a line who can go, one way or the other. Well, then the line meets a circle or a square, or, a polygon, something with more shapes. And it's just goes from one dimension to two. Well, if you don't know that other dimension works, and then later through the story, they meet a cube or a sphere, okay, and they're talking to him and they're telling him, yeah, come up here in the up here in this dimension, height off the flat paper. And the things on the paper are like, you're insane, you're ludicrous, you're a lunatic. There's no other dimension. You can't come off the paper because they're living in two dimensions versus three. It's a fascinating. I read it my freshman year at college. It was required reading. I'd even been in engineering class. I can't remember. It was just a wild book, though. Amazing. Flatland. And people kind of deal with that. You get so inured and immersed into living life with certain restrictions that someone comes along and says, hey, we found a way to remove that restriction. And it's just saying, hey, how's that work? That's cool. People just get angry. They're like, I think sometimes, and I go through this myself too, and maybe this is human nature, where you kind of get locked in with something. You think you sort of feel, how life's working, and you don't know everything, but you know enough of what you're trying to do. And like Malcolm Gladwell says, 10,000 hours make someone an expert. So you're settled in with your job and you just kind of do the same thing, and you're coaching kids sports teams, or you're involved with friends, or you're doing something, your life's good. You go skiing, you go surfing, you're doing your deal. And then all of a sudden someone says, hey, there's a way you could be a lot better with like even work easier, but it requires a shift to step up to that. And a lot of times it doesn't even require money or anything. Just sometimes it just requires your brain to move, right? And it's like, and that can hurt. What was it? There's a guy who said that people hold on to their opinions and their beliefs with a fervency that is just defies logic sometimes. And I'm not talking about religious ones either. A lot of people get into that religious fanaticism. People freak out about it, right? Worldwide. Don't talk about religion and politics, okay? But think about that. Well, how many people freak out over economics? Hey, there's a better way. How dare you say there's a better way? I've been burned before. I've been blah, blah, blah. And you just, out comes the fuselage. I walk into some meetings now, whether on the phone or in person. Sometimes, seriously, mentally, I'm saying, I got to let the first 45 minutes go to let people just rant and rave. And then you get to the end of that and say, do you have any more questions? How can, because we've taken time over 50 years to figure out how to solve this stuff. Okay. So it's not like we just woke up and said, we're going to trick everybody and say we can, use photosynthesis to make algae from CO2. Okay. It happens. It's a matter of harvesting it and doing it right and everything else. And the proof in the pudding of too good to be true. It's like it takes money and a footprint and space. But so here's what's going on, and I'm still working on this. Is the the fundamentals of what we do have been whittled into this modular technology. I've coined it the modular plant single unit, and it came from a 72 ton per day system input to make all these other commodities, including graphene. And the energy and mass balance checks out. I think it was you, Jocko, up in Finland, kind of saying some engineers somewhere were looking at it and they said it's okay. It's like, yeah, I know. I'm an engineer too. I know how to do an energy balance. There's nothing that defies physics in what we're doing. Okay. There's a thing called heat recovery and utilization of waste heat, utilization of waste byproducts like carbon dioxide to make things other more valuable. And that's not, it's actually stewardship. It's actually wisdom. I think that's where some of the chip comes on the shoulder because you get in the dogfight over it. I'm in a fight for this. I get it. I mean, my life's on the line, for this organization has been since I started it. I didn't really realize that at the time, but it has been all along. And I'm happy to be here. No place I'd rather be. But I'll tell you this on the whole thing is how is that irrational to use good science and emerging new sciences? See, when you have a full system together, if you have a factory somewhere and you're building auto parts and cars and you're building a finished product, bicycles, cars, something like that, and then all of a sudden someone comes along and says, hey, we've got a better disc brake system. It's 30% less expensive and it's built leaner and better, and you can retrofit it into all your cars. You're going to have your team look at it, right? Because you're putting in thousands of them a year. So you just, but and who's in a position like is your average guy going to go out and say, oh yeah, I'll buy into the better brake system? At home, you're going to do a brake job and go get the discounted price because by the time you buy one down at the store anyway, how much are you going to save? We're talking factory level stuff where people are doing thousands of things a day. If you can cut prices by a little bit, you make a big difference. That's all we've ever done. But we're in a position where we can take advantage of that, right? We can use the advantage to say, like, if you're a factory building automobiles and a better disc brake comes along, or a drum brake, or whatever, anything, a transmission, a differential, whatever, and it's coming out on the market. Boy, if you're an automobile manufacturer, you're the guy who can really break that in because you're buying thousands of them. So you're the guy paying attention to that. That's the role we've been in for energy, food, air, and water, looking at breakthrough technologies where we can insert into our equation. Because say on the brake analogy again, so an automobile suddenly has a different brake part come in. It still fits in the same chassis, everything else is under the wheel well, and everything's okay. And they've confirmed that, or they make an adjustment so the next year's runs come down like that. Well, yeah, those guys, they're going to be tooled up and put that in, but they didn't really have to change anything to adopt that, right? They're just in there building cars and they just suddenly get better parts and a better deal. Well, that's all we've ever done. It just so happens when we get better parts and a better deal, or we invent some of our own, which most of our patents, and then some we partner with others and blend it all together, just you're getting the best thing possible. That's all it is. It's just integrating the best systems. And I say that because our latest thing, this modular plant single unit, 72 tons a day, developed on a regulatory issue up in the United Kingdom, can now basically, if we have more equipment or more material to process, it's just more of the modules. It sounds simple, right? It's just in parallel. It's kind of like a Lego system, and that's the deals I drew up today. If you're if you're playing with Lego and you want to build a bigger Lego house or dam or a wall or a home or whatever you might be building with Legos, an airplane, a truck, all kinds of cool things, right? Lego's awesome. Lego, let's go. It stands for let's play, I think, or have fun or something. But uh, the whole thing with that, Legos are a great thing to play with, and you can build all kinds of stuff. And we've all seen it now. You go to Legoland in Carlsbad, California, and there's like you can walk around in the building. It's got so many, and it's got millions of Lego pieces. Well, were the Lego pieces bigger? I remember when I was a kid, real little. My brother had the small ones, and I was one or two or three or whatever. And so my parents went out. I remember it got like the bricks were like almost the size of a real brick, but made out of the plastic stuff. Probably wasn't Lego, some other knockoff brand. And they just so I could see it better, and I'd build my thing and go on. I was just a little kid. I remember seeing them later, and that was cool. But we're not talking about making bigger bricks. We're talking about just taking multiple of the same brick and building a network and building up a wall, a house, or whatever. So that's what we've got now uh, uh, in energy, food, air, and water. Nobody's ever been able to do that. See, the whole world's at where this discussion came up, and you guys hear it too. Um, the uh, um, the whole thing with getting projects together and doing pilot plants. Everybody wants to do that. Have you done a pilot plant? Have you done this? And it's like we still have to explain that too with the different vocabulary. And that's what I'm ultimately getting at is that let goat is play well is what Lego stands for. Leg goat in Danish. Um, but the thing that I'm saying is when you need to have these verifications that pilot plants and everything else, we scaled down from thousands of megawatts. So the smaller we got, I used to get quoted. You could look back in it. It was called distributed generation (DG), and the whole concept was to have if you had cleaner, more efficient power, you could put it closer to the load centers. Instead of a remote big power plant, you could have smaller plants closer to where people live if they're clean and efficient and using waste streams. And we set out on doing that. Many in the industry call it cogeneration or tri-generation, where the waste heat is used in a process somewhere and you're getting involved in how the stuff is used. And it was just a natural fit for us. We were just like, hey, yeah, that's how this stuff works. It's just you use the waste heat. You're a steward of what's taken place, and we've just carried on that path. And so then people come in now and say, "Have you done a pilot plant?" And it's like, good grief, man. We've done full scale plants. We're scaling this down. And now we've got these modular plants. And then because we're getting ready, I'm going to show you this map here in a second. We're doing all this stuff um, is with coal conversion. See, because a lot of people too want to say that we convert waste into stuff, waste to whatever, everything to graphene, waste conversion. But fundamentally, we're still not just a waste conversion company. It's coal, oil, and gas. We're a power plant company. But we just so happen now can take coal or oil or gas, any of the fuels, anything with carbon, and convert it uh, um, into ultimately graphene through our system at this very small scale, which turns out in the graphene world is a very large scale. I'll give you the frame of reference there. See, people want a pilot project. This 72 ton per day module, which is like 1/100th the size of a typical power plant setup. But if we're going to come back and do a bigger coal plant, we'll just put 100 units in. It gives all kinds of reliability. They're modular, simple. It's awesome. And what's cool. We're running into the data center projects. So if we have 100 units with 100 generators or 50, one on two, we space it out somehow. But we're into these high numbers of individual units that are, normally a power plant might be 2 or 3 turbines or whatever. We're coming in with 50 or 60 or something. It sounds ludicrous, but the data center guys love it because we have high nine reliability. And these are efficient systems. They're just awesome. And then the guy said, well, that's a lot of labor. Well, we value human resources. I'm sick and tired of that too. I've been in this industry so long, these accounts, every labor, labor, labor. You know what? If you're involved in the work, in what you're doing in manufacturing and stuff, and you cry about how you have to whittle labor and job rate and pay rates down, shame on you. Shame on you, Americans who farm stuff out, do all this stuff. It's one thing if you want a competitive edge, but you know what? If your biggest price in your business is labor and you got to stick it to the guys and fight and fuss over their wages and stuff, then develop your business so it's better. See, we at Concentric, we're excited to hire people. And you know what? We want to hire extra people because there's places like Kinshasa DRC or in Kampala, Uganda, or in Jakarta, Indonesia, Manila, Philippines, where there's so much garbage. To Tunisia, we saw it. It's not really that bad in Tunisia, but you know what? The landfill's so discombobulated and far away from town and different problems with it and everything else that there's just garbage in the streets kind of in general. Not real bad, but noticeable all over. Because people are like, what difference does it make? What are we going to do with stuff? Well, what if we could just pay those people like a couple dollars a day to get a bag of trash, like in India or over in Bangladesh or some of these places where people just live in total poverty? And I've read Carl Hoffman's book, you know, what's it, the Lunatic Express. What a great name, even on that. Read that book. You'll see, because it's indefatigable people around the world who eke out an existence traveling on these terribly dangerous planes, trains, ferries, boats, all this other stuff, just to eke out a living to basically make sometimes the equivalent of 5 or 10 cents more US a day. So we could go out and give $1 to people to pick up, hey, we're going to have a beach party there in Java, and go down to the beach and you've seen it if you've been down there. There's just trash all over the place. It's in the water, it's all over the beaches, the whole deal. It's just little stuff, paper cups, plastic. You hope it's not condoms or whatever. It's kind of gross. But you know what? It's fixable. What if you could have parties and go out to the people and say, hey, look, everybody in here, you get $1 a bag. Kids who, if you work your tail off, some kid in junior high down there, it's like you work real hard somewhere in a restaurant or somewhere else, you might make $1 a month. We'll give you a couple dollars a day just to help clean up your community. Why? Because we can afford it, because we're going to turn it into something valuable. And then later you have transfer stations, and then the stuff won't get into the garbage, into the rivers and lakes and oceans. There's just simple solutions here that we can value that. And again, we're excited to have found graphene, which is such a high dollar material, because it changes the whole equation. We can start to think long term and socially. How can we have impacts? How can we give back money to the different communities we're involved in? And uh, the great part about that is that it's just a forward thinking deal where we're like, hey, we want to train labor, have a training institute, do these things that make sense, be a part of the community, not just come in and take resources. And I think, again, that's a different language, right? If you guys haven't seen it, look up the resonance. I knew this would be an issue. So probably about a decade ago, well, quite that long, 7 years ago. But prior to that, I was thinking about it. But it was July, actually almost a year ago. It would be 7 years ago. I gave a speech in a Toastmasters called the Welcome to the Resonance, and the transcript is on our website. I was thinking of reading all. There's 4 speeches now. There's introduction, and then there's a 1, 2, and 3, and all 4 of the transcripts are on the website. And I came up with this thing called the resonance, because this is a movement. If we get this much stewardship, this much everything, and utilization and optimization of waste and fuels, then why not uh, put together a movement? Right? There was the Enlightenment, the Industrial Revolution, the Renaissance was a famous movement. Why not the resonance? Because we're getting in sync and in tune with how things naturally work. So we're running with that. And I'm excited about that term. It's kind of embedded in our culture, because we're synchronizing and getting in phase and in sync with how natural things work. And the whole thing behind that is that as I say in the intro, and it carries out throughout, and it's still part of the ethos of this company, is there's 4 things of what we do. See, there's a Simon Sinek, the golden triangle. There's what you do and why you do it. People follow why you do it. Well, we were fortunate because we already had a big why. And the why was so people could have quality of life, right? See, what we do, energy, food, air, water, meeting people's physical needs, that's all that is. See, I'm the first person. This is where people make it too complicated. Concentric is not a technology company. Even with all our engineered patents, we build plants and everything. You know what we are? We're uh, quality of life company, the habitat engineers, making life better. People want to compartmentalize. So you build power plants, you have engines, hydrogen and pyrolysis, where all that stuff's critical. It's vital to do it properly, but it's not what really matters. And that's where some people get lost. They're like, I'm not good at math. I don't understand science. It doesn't matter. You need energy, food, air, and water. You can support truth. You can find people who have some, and I know the burden's on us to go raise capital and get back on track and prove it again. The 128 plants we put in to lead the world basically doesn't really matter to some people because what have you done lately? Okay, fine. But here's where it comes down to is that you end up putting all this work together and you optimize things and you come out with better solutions. And all of a sudden it's like, whoa, nobody knows what we're talking about, or very few do. We need to change and learn a new vocabulary. And that's why the resonance came along and all these different things we're coming up with to try to explain to people that look, all we're doing is making energy, food, air, and water more cost effectively, and it just so happens now we have a byproduct. This is great emerging material for use all around the world, and we can have upside in it as it gets made. And this is the statistic I wanted to give you, and I am still looking here, and I'm sorry I didn't prepare for this in advance on the YouTube thing. But the story I want to tell you is the whole deal of the global production of graphene is not even 1% of the global demand. And the demand is so big that most of the end users don't even do anything with it because they're just waiting till they can get some. Right? They've got end uses for it, but it's like nobody's mass producing. Well, we walked into that and said, we'll mass produce. And you've seen there's stuff available all over our website. It's there. And the whole idea that with graphene, there's end uses we haven't even thought of yet. Well, we're going to be in right in step with that. And here's why. All we have this 72 ton per day modular plant, single unit. Depending on the exact feedstock, the carbon content, of course, because it's conservation of mass. There's anywhere from 4 to even up to 16, but we're starting to model like 4 to 6, 8 tons a day, somewhere in there, 4 to 6 tons a day of graphene gets produced. And graphene pricing, a lot of it is over $1 million a ton. A lot of it's in the 50,000 to 100,000, 200,000. So we kind of model down in that low end, and we get these enormous returns that are like 1 month simple payback on projects that historically take 3 years, kind of thing. And so it's phenomenal. And what's going on the graphene basis is that even if we use say 6 tons a day or 4 tons a day, kind of the low end of the production, like garbage is the feedstock, so your fuel properties are the weakest, and we come out with 4 tons a day times 360 days a year and do the math and run it out, and you got thousands of tons a year of material, and here you go. Here's what's wild. We need 6 of our modular plant single units, just 6, half a dozen, will make us not just the world leader in graphene production, but more than the rest of the world combined. Okay. And we have 20,000, actually, it's about 28,000 backlog now of those. And we're getting factories built in Oman and in Georgia to support that. And we're looking at saying, how are we crazy? Because the demand is there. The demand in the cement industry alone wants it all over. And we can use cement kiln emissions, the CO2 to make algae or moss to then make more graphene. It's a circular loop, that Dariel 360. Uh, um, so uh, the that's where we're at number wise, is we're just so far out in front of the curve. And in some of the dialogue we've had with everybody, we know that there is um, um, the uh, um, what am I trying to say? And sorry guys, I'm on my smartphone here. It's got better audio than my MacBook, and I'm still trying to hold on 1 second here. Hey Talita, are you up there? I'm trying to go through the commands, and sorry everybody, I'm just going to do this live here. I've got a whole screen full of instruction sets. Can you just help me interpret this so I can think while I'm talking to these guys? What do I need to do here to do a live screen share? I see a bunch of commands, but it looks kind of different whether I'm on the phone or computer. Can you just help me? Thank you for doing that. I really appreciate just I'm thinking it's one of these buttons here to do it. But the reason I want to share that while she's looking, and thank you guys, I appreciate it. We're selling right now. We've been out, and some of you who are directly involved, that we're doing some amazing designs. We're doing some absolutely phenomenal project designs. We're starting to post more and more of them in, at least our team groups in WhatsApp. and some of the information's getting out into, these are projects we've designed, and we've done millions of dollars of engineering, over the course of just these last couple of years since we got kind of out from under the thumb of not just Uncle Sam or Big Brother, but some super toxic stuff um, in the Western United States. We got out from under that, and here we go. Green screen. Thank you. Oh, cool. There's that in the background. So I will use that here to talk through. This is one thing I wanted to show you. Thank you, Talita. So I've got this in the background for me now, and I'm going to walk through where we have some developments. I want to be really clear on this, though, that the information we've done, some of you maybe have seen some more or less, whatever, but realistically, the amount of work we've done and everything behind me, it's got a whole full blown map. I think I'll be able to move it. Maybe not. I'm just getting some of it. Let me hold on one second. Let me pull that back up again. Or no, I guess I'm there. I'm going to try to figure this out. I was hoping, hold on one second. Is there a thing that can put like the picture up in front of me, not just the backdrop? Because like, look at this. I was trying to show them the world map, and I'm stuck on just that center section, which is a great area. But I've got stuff in Asia and Africa I want to show too. It's not really giving me a dynamic. Like, you know what I'm talking about is having like the bubble, like there'd be the live something. I see guys do that on YouTube. Sorry guys, we're experimenting on this. We'll get it figured out, and I'll walk through the best I can here on things. Here's the latest. I don't think we want to go there. This is as good as I think it'll get, I guess. That's not really like a screen share though. Hang on, everybody. We're going to work through this. If anybody does know how to do a screen share, and I know this is really unprofessional, everybody, but we're just going to wing it and do the best we can here, because I do want to show you some of this information. I'll keep looking it up here. It's fine. Well, I'm trying to. What I do want to share, though, is that we've done millions of dollars. Like really, if you take our engineering work that we have done on this already, we have done millions of dollars, probably over 100 million in actual engineering work to optimize all of these kind of systems. And what it says, hold on one second, Ian. It says there's no single key. You got to go to control center. Well, where's that?
It's this.
Okay.
Yeah. Or you can't really do it from your phone.
Screen recording icon.
They might only be able to do it from your laptop.
Okay.
That's what I'm thinking.
Okay.
Because this is the control center.
Okay.
That's what we have to work with.
Single circle inside in there. Huh. Okay. All right. So I've got this in the backdrop, and we're going to get this figured out. I've seen guys doing some professional presentations and some, even on the brand new Rush tour. If you guys have seen any of that, there's people taking awesome footage, with their cameras or phones, from right there at the concerts that sound pretty good. They look great. So we should be able to do some here. So we're going to keep working on that. But what I want to talk to everyone, you can see, I'll start with just what's behind me here. Yeah, but they do have a sharing thing. If you wouldn't mind.
There's no single keyboard button within the YouTube app itself.
Yeah, I know, and we were. Hold on one second.
On an iPhone.
I know, but then there is the way to do it.
Use the iOS controls.
And that's what this is, but we're still not finding it. So, okay, let me just show you what I can show you, and we'll figure it out as we go here. Let me keep trying to kind of take a look at this stuff. What I've got behind me, and I'm going to kind of get out of the picture so that I can talk about it and you can see it. This is, we're in Tbilisi. And see on this, I know it's not a screen share because I can't really zoom in either. And so this isn't really what I want, but at least it gets me something. And if you look up here, do I even have, yeah, there we go. I'm like the guy doing the weather. You come up here to, let me follow along. I've got to get so far away from it now. I can't even see it. Just a second. There's order to the madness here, guys. You go up here, and there's Saudi Arabia. So you come up Ankara. Oh, there's Turkey. Uh, Here we go. Yeah, there's Georgia. Okay, right up here on the Black Sea, the blue dots there. That's where I'm in Tbilisi now, and we've got a whole bunch of developments, more than just those four. But if you look on here, everywhere you see a city indicated and a dot, we've done at least on the order of a couple $100,000 worth of engineering design. And we do it fast now because we've got a modular system. But still, if someone had to start from scratch, it's probably even more than that. How we get on our systems, and this is part of that engineering budget that's in every project. And we'll